evening. Welcome to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and today we're going to get into some areas of surveying. Now, a number of individuals, when they look at surveying, they think of a person out there that's setting up an instrument, taking an HI, which is the height of instrument, running a plumb bob to make sure that it is plumb, and then you have what we call a rod person. He's going out there with a Frisco rod or a prism to stake out points. Well, that is part of surveying. That's known as plane surveying. But there's another aspect that has caught on in the last 20 years, and it is mapping. It's geographical information systems, known as GIS. Now, I'm going to share my screen, and I'm going to give you an overview of what GIS really is. All right. What is GIS and its components? What is GIS and its components? Now, when we talk about geographical information systems, in IT, there's management information systems, there's information systems, and there's geographical. When we mention the word geo, what are we talking about? We talk about geotechnical, geological. We're dealing with the earth. Geo is the earth. So when we talk about an information system from a geographical standpoint, we're basically dealing with a systematic integration of hardware and software, and that is basically used for storing, displaying, updating, manipulating, and of course, analyzing spatial data. GIS, short for Geographical Information Systems, can also be viewed as an interdisciplinary area that incorporates many distinct fields. Again, GIS can also be viewed as an interdisciplinary area that incorporates many distinct fields of study. Now, a number of individuals would look at it as just employing geography and cartography, which deals with maps. That is one aspect of it. However, as I go on, yes, geodesy. That's number one. That is basically projection, surveying, cartography. Cartography deals with map making. Then you deal with remote sensing, photogrammetry. Now, how do they use photogrammetry? Well, you can use a drone to take pictures of parcels, of roadways. You can even use it to take pictures of bridges. You're creating a map. Environmental science, city planning, cognitive science. GIS has so many good uses. ARC systems or ARC mapping, that's a software that you can utilize with CAD for all of your GIS information. Now, as a result, when it comes to GIS, it relies on progress made in the field, such as computer science, databases, statistics, and of course, AI, which is artificial intelligence. Again, we point that out to you again. GIS relies on other fields. That's why it's interdisciplinary. It deals with computer science, databases, statistics, and artificial intelligence. Now, all the different problems and questions that arise from the integration of multiple disciplines that make GIS more than a simple tool. Now, what are the requirements for GIS? Well, geographical information requires a means of integration between different sources of data at different levels of accuracy. System basically deals with the aspects of daily life, so it must be updated daily to keep it current and reliable. Much of the information stored in GIS are for practical use, and it requires a special means of retrieval and manipulation. GIS system and application basically deals with information that can be viewed as data with specific meaning and context rather than simple data. Now, with every computer system, when you get into computer systems like management information systems, you have to understand the components. So let's look at a GIS system. It's basically an integration of three components. It's hardware, software, and people. Now, again, hardware and software. Hardware relates to device used by end users such as graphic devices or plotters or scanners. Data storage and manipulation is done using a range of processor. With the development of the internet and web-based applications, web servers have become part of many systems architecture. Hence, most GIS, it basically follows three-tier architecture. Now, the software parts relate to the processes used to define, store, and manipulate the data, and hence it is akin to DBMS, Database Management Systems. That's what DBMS stands for. So different models are used to provide efficient means of storage retrieval and manipulation of data. Two, we got data. Now, geographical data are basically divided into two main groups, vector and raster. Vector data / layers in GIS refers to discrete objects represented by points, lines, and polygons. Now, there's something else that is also represented by points, lines, and polygons. That's AutoCAD. And when you utilize AutoCAD, you put everything on layers just like you would on GIS. Now, lines are formed by connecting two or more points and polygons, and polygons are basically a closed set of lines. Now, layers represent geometries that share a common set of attributes. Objects within the layer have mutual topology. Now, vector sources include digitized maps, features extracted from image surveys, and many more. Now, raster data is a continuous grid of two cells in 2-dimension, or the equivalent of cubic cells in 3 dimensions. Raster data are divided conceptually into categorical and continuous. Now, in a categorical raster, every cell value is linked to a category in a separate table. Examples: soil type, vegetation types, land suitability, and so on. Continuous raster images are usually describing continuous phenomena in space, such as DIM. DIM is digital elevation model, which each pixel is an elevation value. Now, unlike the categorical raster, a continuous raster doesn't have an attribute / category table attached. So a typical raster source, what it is a satellite image, a scanned map image, or aerial images. And people, when it comes to people, they're involved in all phases of development of a GIS system and in collecting data. They include cartographers and surveyors who create maps and survey the land and the geographical features. They also include system users who collect the data, upload the data to the system, and they manipulate the system so they can analyze the results. So basically, when we deal overall with geographical information systems, I'm just going to tell you again, it's basically defined as a systematic integration of software and hardware for capturing, storing, displaying, updating, and manipulating and analyzing data. Again, the geographical information system is basically defined as a systematic integration of software and hardware, and that's used for capturing, storing, displaying, updating, manipulating, and analyzing spatial data. And when it comes to GIS, GIS is interdisciplinary. And what do I mean by interdisciplinary? Because some people get that context. When you have something that's it's between fields. So I can go between business and I can go between forensics with GIS. So you can go between two fields, where if something is multi, it's two or more fields. Just remember that. And again, GIS is used for mapping, and you can use it for creating maps from other maps. You're getting data, you're storing data. It's a system. It's an information system. And when it comes to GIS, what you have your components. You have your hardware, your software, and your people. That's what you have. And your computer components, again, hardware, software, and people. And you also have data. Because if we didn't have data, we couldn't make maps. So again, that wraps up this segment of GIS, Geographical Information Systems. If you like what I just presented, please comment, share, and subscribe. Again, I just want to thank you all for just listening, because it's very important that you understand what GIS is. GIS is Geographical Information Systems. And for all of you who are interested in more of my content, you can check out the 411 Talk Zone Radio Show channel. On that channel, that deals a little bit more with the social issues, political issues. That's my main channel. Now, if you cannot find my QCIS channel, or if you can't find the 401 Talk Zone Radio Show channel, I apologize if I'm stumbling a little bit. I'm just trying to shorten my videos so you can get the information that you needed, so I won't be too long-winded. But I like to teach, and I teach by repetition. But again, if you can't find a QCIS channel or the 401 Talk Zone Radio Show channel on YouTube, you can check that channel out, both of those channels out on Twitter. Now for the QCIS channel, take it one step further. Since it is an educational channel, you can always find that channel on LinkedIn. Once again, I thank you for viewing this video on GIS. Till next time. My name is Leon Jones. I want you all to have a wonderful and gracious evening.